A very good day to our lecturer and fellow classmates. We are Group Sanrio, and today we are excited to present Campus Track, our real-time bus tracking application for campus transportation. Before we move on, I would like to introduce our group members. We have Hana Shakira, Lau Shibin, me, Andrew Loisuki, Faiz Liana, Nabil Najwan, and Dwi Hidayat. The core problem we set out to solve is one that almost every student at UM faces daily. There is currently no easy way to know where the campus shuttle bus is in real time. Students wait at the bus stop with complete uncertainty, wasting time while drivers lack a system to report their progress, and administrators have no centralized platform to manage the routes and fleet. To address this, Campus Track connects three key roles into a single workflow. Firstly, we have the administrators who manage the routes, stops, and buses via a secure dashboard. Secondly, we have the drivers who start trips and submit live GPS locations from their phones. Thirdly, we have the students who can view the live bus movement on the map and browse route stops without even needing to log in. Here is our system architecture. Campus Track is built using a Spring Boot microservices architecture to ensure modularity and scalability. At the front layer, we have our client applications, the Angular Admin Web App, the Driver Ionic App, and the Student Ionic App. All requests from these clients do not go directly to our services. Instead, they pass through our Spring Cloud API gateway. The gateway routes these requests to their respective backend services, authentication, route, stop, bus, trip, and location services. Each service is completely isolated and talks to its own dedicated PostgreSQL database, ensuring a clean separation of concerns. Now, let's trace the most important data flow in our application, the real-time GPS path. It stops when the driver's phone captures GPS coordinates and sends them via a post/API/location request. The gateway routes this request to the location service, which precedes the coordinates with a timestamp into the location DB. At the exact same time, the location service broadcasts these coordinates to a WebSocket endpoint. In this case, it's the /ws/location/live endpoint. The student's application connects to this WebSocket to receive instant updates while also using the get/API/buses/live fallback. This is how the bus marker moves dynamically on students' map without requiring them to refresh the page. You might wonder why we choose to route everything through a Spring Cloud gateway. Aside from acting as a single entry point, the gateway handles our JWT authentication and CORS configurations. For instance, when an admin or driver logs in via the authentication service, they receive a JWT token. For all subsequent requests, the gateway intercepts the token and validates it before forwarding the request to the internal microservices. This means our individual services like route or bus don't have to repeat authentication logic, keeping them lightweight and secure. Next, I'll pass the floor to my groupmate to demonstrate how the admin dashboard manages the data.
Thank you to my teammate. Thank you to my teammate explanation of the system design architecture and also the finance demo. Now my name is Marchibian and I want to explain the BED API. The BED API CI/CD pipeline and also the challenge and also as well as the lesson we learned in these assignments. So first of all, our backend is provide the 23 REST API endpoints across the six Spring Boot microservice. The endpoint use the node voice access control RDSC for the admin and also the driver, while the student-facing route, stop, and the light bus informations remain publicly accessible. So now I will demonstrate the security exercise using the Spectre. So the first flavor is the auth controller. So it's for the user to log into the systems, which are the driver and also the admins. And now I want to demonstrate the admin ones. So the email I use the emails and also the true power and also the true password as a keep. So it will return the 200 codes. provide the network login successful and also provide the access tokens. This access token is provided by using the JWT tokens for the user to access successful the different service in this system. And the token type we used is the bearer. And now we move to the second one is the route controllers. And the route controllers, the stop controller and also the bus controller are almost the same. They use the CRUD for react, read, object and also the delete. So now I demonstrate the get ones. Execute. He will return the 200 codes and also he will get all the route in this system. The stop is also the same. He will return 200 also the stop in this system. The bus also as well. This also the same. And now we move to post and we move to the trip controller. Trip controller is used for the drivers. And when the drivers start the trip, the bus will return the information like the location and also the time. Uh, similar like not sim- it's like the live bus location controller. So for this one, I find out the execute. He will return 400 codes and also he will return the live bus location which is successful. So you can see the trip ID, the bus ID, and also the locations, longitude and longitude, and also the record X. Record X, which means the timestamp. This timestamp the report will refresh every 5 seconds by using the red sockets on the driver system. So now we move to the Docker part. And then this system is containerized by using the Dockers, each Spring Boot microservice and each Postgres database are run in a separate container, so we can see all the all the Docker image represents different containers. So the client will enter through the Spring Cloud API gateway, which provide one entry point and the route each request to the Bread microservice. And then the systems deploy on a to the cloud virtual machine. So you can see the virtual machines. The virtual machine name is a campus track connections that will provide the internal IP for the inside access and the external IP for the user to access. And we also use the Cloudflare for this assignment. So you can see the campus track connection is send them as a virtual VM the VM in cloud. This depend on the VM name and also the IP address. So the top will provide our public domains, so we can see the domain name, the campus track within that, the comps. This is the domain name. So the cloud will provide the public domain names, the HTTPS, and also the secure tunnels to the server without direct exposing to the virtual machines application ports. So the port is this 3, 4, and so on. This product the user can directly see the actual IP address of the VMs, the virtual machine. So, what is the flow of the user visit these applications on the user applications or the website? They go to the Cloudflare DNS, HTTPS connection, and also the Cloudflare tunnel. They move to the Nagix reverse proxy and then move to the API gateway. The API gateway will depend on the user request to go to the prefer service. And then we'll go to the microservice, which means the backend service. And now go to the last one is the progress database to return the data to the user application or the website. So now we move to the last one is then that's all for this and then move to the CD part, CI/CD parts. So we also implement the CI/CD pipeline using the GitHub Actions. Whenever the code is emerged into the main branch, the CI workflows run automated tests and build the Docker image. And then the image will public to the Docker Hub and the GitHub container registry. The CD workflow then deploy the latest version to the Google Cloud, and this make our environment deployment rate reproducible and ensure that the changes are tested before reaching the cloud system. And now we move to the last one is the challenge and the lesson. So during the developments, our main challenge are integrating the multiple dependent microservice. This service and the database work separately, but it is still needed to support one compact user flow. And the second one is a real-time GPS pointings was another challenge because the driver locations, the work socket updates, and the student map had to remain synchronized. And through this segment, we also learn some things. We learned that the cloud deployments involve more than running the applications. JWT security, the Docker, networking, CI/CD pipelines, the reverse proxy configuration, and also the service monitoring must all work together. So the main The lesson we learn is also to define clear service responsibility, test the complete user journey, and automates deployment as much as possible. So in summary, the campus connect the admins, driver, and the students through the secure microservice platform. The admin manage the transport data, driver provide the live GPS location, and the student track the buses through the map. And this system is configured, automatically deployed, and publicly accessible through the Colo Cloud and also the Cloudflare. So that's all for me and for our groups. Thank you for watching.
Assalamualaikum and hi everyone. My name is Hana Shakira. My matrix number is 299403. So now I'm going to present to you the admin part, where in the admin part, once you enter the correct credentials, you are on the overview section where you can see the total buses, total trips, total stops, and total routes. So here are the quick actions where if you wanted to manage routes, stops, or buses, they will straight away proceed to the respective panels, where in this route section you can create a new route and add a description, and you can also edit or delete the routes. So these are the stop section. So in stop section, you can click the route you wanted, and here are the list of stops that you will see in the route. So I just recently added PKU, which is the newest route and the sequence number. So if you wanted to delete this, you should be able to delete the stops. As you can see, the PKU is deleted, so there are now only 14 stops left. So here are the buses where you can add new bus or you can delete the bus. So assuming that you wanted to delete a data, where it will provide a confirmation whether you wanted to delete a bus for a specific path. So if you click OK, it should be able to provide a notification that the bus has been successfully deleted. So that is it for the admin part. Thank you.
Okay, now I will give a brief explanation about the driver app. So for the driver app, for the flow is the first, the driver need to log in to the app first. Okay. So when after the driver login, they will be redirected to the main dashboard of the driver, which is they can see the map and this card here where they can select their bus, such as for what bus that they are assigned to that day. For example, this one. Then the driver need to and then the driver will see the stop of the route for the bus. For example, like Inal 60M, Inal 60SN, and when the driver press the start trip, and then the status will in progress, and the GPS status now is active and sending. So when we look at the student app, we refresh it. So right now it is live. So the student can see the bus right now. And then after the driver finish their shift for that day, they can press the end trip button to end their trip, and that's it. And then they can log out.
Assalamualaikum everyone. So here I will demo for a student app. So at the top is the catching title. So is where is my bus. In that, and the place name is that our specific requirement is in a University of Malaysia. So in the below plan your journey campus routes. There are 7 campus route that we are put in this student app. So when the user can select any route that they want to take a look. For example, I want to look at the route 2, which is from Maybank to Petronas and to Academic Hall. So when I select the route, the map will show how the bus will go through. Later, my partner which is Faizana, will tell more details about how the features work. So I will just tell when the user press any of that selected route, it will give the detailed information of the route, and it shows at the live campus map how the route will work.
So hi, my name is Nur Faizana. So I will be showing the route and then the stop details in these sections. So for example here, if we click any of the campus route here, for example Tradewin and Proton, so it will display the stops in order. So this helps students to clearly understand the sequence of where the bus stop will be next. So the route also will be displayed here at the map, and then these yellow dots like represent the bus stops. So let's say if we click any of them, it will show the stop details such as the stop name and then its sequence in the route. So for example here, if I click Inasismas, the map also will display the stop information here, including the stop name and its positions in the route sequence. So now we currently only have like one active bus 2014. So ideally it will show the bus moving in real time around the route, but however, since I'm the one that running the driver app for this demo, so the location appeared static at the moment. But then if the driver's GPS is like actively updating, you would be able to see like the bus icon like moving along the route in a real time. So that's all for me. Thank you.